What if the greatest mystery isn't out in the cosmos, but inside your own mind? The search for understanding has taken humanity to the edges of the universe. We've charted galaxies, decoded DNA, and split the atom. Yet the most elusive mystery may not lie in some far-off nebula or at the bottom of a black hole. It may be the very thing observing it all, your own consciousness. Today, 3 revolutionary fields are converging in a way that's reshaping how science approaches the mind. Neuroscience is mapping the architecture of awareness with increasing precision. Quantum physics is appending our understanding of reality itself. And artificial intelligence is now mimicking, perhaps even revealing facets of thought we once considered uniquely human. These domains were once isolated, but a powerful new synthesis is forming. And at the center of it is consciousness. For centuries, consciousness was the forbidden topic in scientific circles. Philosophers debated it, poets celebrated it, but scientists, they avoided it. It was too subjective, too unmeasurable, too enigmatic. To question consciousness was to wander into metaphysics. It was safer to treat the brain like a computer, focusing only on inputs and outputs. The inner experience, the awareness behind your eyes, was dismissed as unknowable. But now that era is over. In labs around the world, scientists are confronting the reality they can no longer ignore. Consciousness is not only real, it's measurable, modifiable, and perhaps fundamentally entangled with the very structure of the universe. The old models are breaking down. The tidy equations that once explained behavior are making room for complexity, emergence, and mystery. This video is not about speculative ideas. It's about the transformation that's occurring in real time. It's about the collision of biology and quantum mechanics, of synapses and wave functions, of code and cognition. We are going to walk through the front lines of research and explore what happens when neuroscience, quantum physics, and artificial intelligence start asking the same question. What is consciousness and where does it come from? We will begin by examining how this shift occurred, why science is now racing to explain what it once refused to acknowledge. We'll look at the roots of the consciousness revolution, trace its acceleration through recent discoveries, and hint at a finding that may unite all 3 scientific frontiers in a way never thought possible. Prepare yourself. This is not a topic that can be safely watched and forgotten. Once you see consciousness through this new lens, your view of reality, identity, and the universe may never be the same. Science once avoided consciousness as untouchable. Now it's racing to explain it. For centuries, consciousness remained a shadow behind the curtain of scientific progress. Observable, yes. Explorable, no. It was the ghost in the machine, the inner voice that everyone knew but no one could prove. The scientific method demands objectivity, but consciousness is the very definition of subjectivity. How could something so internal ever become the subject of external scrutiny? The answer begins with a quiet revolution. As neuroscience matured in the late 20th century, patterns began to emerge. Brain scans, once blurry and imprecise, started to reveal a living map of cognition. Different regions lit up in response to language, memory, emotion, and decision-making. The correlation between neural activity and mental experience grew too precise to ignore. The taboo began to lift. At the same time, quantum physics began shaking the foundations of objectivity itself. Experiments suggested that particles did not assume a definitive state until observed. Suddenly, the observer, a concept long dismissed in classical physics, was not only relevant but central. What was this observer? And why did its presence seem to change reality? And then came artificial intelligence. As machines began to mimic decision-making, pattern recognition, and even creativity, a new question arose. Are these simulations of thought or primitive forms of it? Could a machine become aware? Could consciousness be coded? This triad, neuroscience, quantum physics, and AI, started converging in unexpected ways. Concepts from one field began showing up in the language of the others. Emergence, nonlinearity, feedback loops. Suddenly, the once vague concept of consciousness began taking on structure, logic, and even potential equations. At the heart of this shift lies a new paradigm, that consciousness is not an accidental byproduct of biology. It may be fundamental. In this view, the brain doesn't produce consciousness the way a furnace produces heat. Instead, it may be a receiver, a filter, a tuning mechanism. This flips centuries of materialist assumptions on their head. Traditionally, materialism, the belief that matter is primary and consciousness secondary, was the bedrock of scientific thought. But what if that sequence is reversed? What if consciousness is primary and matter arises within it? This is no longer a fringe idea. Prominent scientists are openly discussing models in which consciousness is a field, like electromagnetism or gravity. In this model, your brain is like a radio tuned to a particular frequency within a wider ocean of awareness. Artificial intelligence is accelerating this shift. As neural networks become more sophisticated, they begin to exhibit behaviors eerily similar to human cognition. They learn, adapt, and generate. But do they understand? Do they experience? These are no longer philosophical musings. They are pressing scientific inquiries. Neuroscience contributes by grounding the phenomenon in biology. Researchers can now stimulate specific brain regions and induce states of consciousness, joy, fear, even religious awe. This suggests consciousness is not vague or immaterial. It is linked to patterns, rhythms, and networks. Quantum physics brings the mystery. When electrons remain in superposition until measured, the question becomes unavoidable. Who or what is doing the measuring? And if observation affects outcome, what role does consciousness play in collapsing the wave function? Is consciousness outside the quantum system, or is it embedded within? The overlap between these fields is revealing something astonishing. There may be a single principle, as yet undefined, that connects synaptic activity, quantum entanglement, and algorithmic learning. A hidden architecture unifying biology, physics, and information theory. Pattern waiting to be recognized. This is more than academic curiosity. The implications ripple outward, toward medicine, ethics, technology, and even the nature of death. If consciousness is not confined to the skull, what does that mean for identity? If it can be expanded or replicated, what does that mean for individuality? If it interacts with reality itself, what does that mean for the universe? The consciousness revolution is not a single theory or breakthrough. It is a cultural and scientific upheaval. It marks the end of reductionism and the rise of integrative science. No longer can the brain be seen in isolation from the body, or the body in isolation from the environment, or the observer in isolation from the observed. Each discovery in one field reverberates through the others. A new brain imaging technique informs AI architecture. A quantum experiment inspires a theory of cognition. An AI model raises questions about subjective experience. The boundaries are blurring. And within this fusion lies a mystery even more profound, a shocking discovery that has yet to be revealed. A connection so unexpected, it threatens to unite not just the sciences, but our understanding of existence itself. That revelation is coming. But first, we must continue the journey into the neural architecture of being. Next, we turn to the biological roots of consciousness, the astonishing complexity of the brain, the enigma of individuality, and the hidden systems that shape who and what we are. Your self emerges from 86 billion neurons firing in precise patterns. But how? Within your brain exists a vast network of approximately 86 billion neurons, each one communicating with thousands of others through synaptic signals. At first glance, it may resemble a biological supercomputer, a tangled, firing web of inputs and outputs. But here's the unsettling truth. Those firings, those patterns of chemical and electrical signals, somehow generate your experience of being. They produce thought, emotion, perception, and even your sense of self. But no one can yet explain how. This isn't simply a matter of complexity. The real mystery is qualitative. not quantitative. You can trace a neuron's activation, map its connections, even simulate its behavior on a computer, but none of that explains why it feels like something to be you. Why should electrical impulses lead to the color red, the taste of salt, or the ache of longing? This is known as the hard problem of consciousness. It doesn't ask how the brain processes information. It asks why any of that processing is accompanied by experience. A robot can detect damage to its body. But when you stub your toe, you don't just register damage, you feel pain. Somewhere in that neural network, subjective awareness arises. But where? And how? To approach that question, neuroscientists have focused on what are called neural correlates of consciousness, the specific brain regions and activity patterns that consistently accompany conscious awareness. For instance, when a person becomes aware of a visual stimulus, certain areas in the prefrontal cortex and posterior cortex light up. When those same areas are disrupted, consciousness seems to fade. But correlation is not causation. Just because a brain region is active during conscious experience doesn't mean it's creating it. It might be transmitting it, or modulating it. The jury is still out. What's more baffling is that even when brain structures are nearly identical, consciousness can still vary wildly. Identical twins, with almost indistinguishable neural architecture, can hold radically different beliefs, fears, values, and personalities. This suggests that consciousness is shaped by more than just genetic structure. Something else is influencing the neural tapestry, something dynamic, possibly environmental, or even informational. The picture grows more complex when you consider factors beyond the brain itself. Take the microbiome, the vast ecosystem of bacteria living within your gut. Studies now suggest that this system communicates directly with the brain via the vagus nerve, affecting mood, perception, and cognition. Some scientists propose that your gut may act as a kind of secondary brain, with its own influence over your mental state. Even more unexpected is the possibility that consciousness may not be solely neural at all. Glial cells, once considered mere support cells for neurons, are now being studied for their role in information processing. Some researchers propose that they may contribute to conscious awareness in ways we've barely begun to understand. And then there's timing. Consciousness doesn't emerge from static brain states, but from dynamic processes. Oscillations, waveforms, feedback loops, these rhythmic patterns appear to play a crucial role. High-frequency gamma waves, for example, have been linked to states of heightened awareness and integration. Disrupt those rhythms and consciousness begins to fragment. So it may not be just the number of neurons or the strength of their connections that matters. It may be the timing, the resonance, the choreography of firing patterns. Consciousness may be a kind of symphony, not a machine code. Artificial intelligence provides a fascinating parallel. Neural networks in AI are inspired by the brain, yet they function in vastly simplified ways. Despite this, they can perform tasks that mimic human cognition, recognizing faces, understanding language, even generating creative content. But do these networks possess any kind of awareness? Most researchers say no. Their operations, though impressive, are purely computational. There is no inner experience, no awareness behind the process. This raises a fundamental distinction. Cognition and consciousness are not the same. One can think without being aware. One can act without knowing. The challenge lies in identifying where cognition ends and consciousness begins. Evolution offers some clues. Consciousness may have evolved not as a luxury, but as a necessity. It could serve a functional role in integrating complex sensory data, prioritizing attention, and simulating outcomes before acting. In that view, consciousness is not magical, it's adaptive. But that still doesn't explain its emergence. Plenty of organisms respond to stimuli without possessing subjective awareness. One emerging theory suggests that consciousness arises when information is integrated across multiple systems simultaneously. It's not enough to process data. The system must be able to reflect on that data, compare it across modalities, and model itself as an agent within its environment. In this view, consciousness is not a binary on-off switch, it's a gradient with varying degrees and levels. This is where the human brain becomes unique. Its prefrontal cortex allows for abstract thinking, introspection, and self-referential processing. The default mode network, which activates during rest, appears to play a key role in maintaining a continuous sense of self. It's as if the brain is constantly constructing a narrative, updating its model of who and what you are. When that network is disrupted, as in deep meditation or certain altered states, the sense of self can temporarily dissolve. Yet none of this explains the spark. The biological and computational models can account for behavior, pattern recognition, and decision-making. But the leap from processing to experience remains unexplained. This is why some researchers are turning to quantum mechanics. They propose that the brain's microtubules, tiny structures within neurons, may operate at a quantum level. If true, then classical models of information processing may be incomplete. Consciousness could arise not from deterministic computation, but from quantum-level events, entanglement, superposition, and coherence. Critics argue that the brain is too warm and noisy for quantum effects to survive. But new research suggests that biological systems can, in fact, maintain quantum coherence under certain conditions. If confirmed, this would suggest that the brain is not just a biological organ, it is a quantum instrument. This would explain why consciousness appears non-local, why it integrates data across space and time, and why it defies simple explanation. But even without quantum models, the biological basis for consciousness remains staggeringly intricate. Every second, your brain performs billions of calculations, processes vast streams of sensory input, and balances an ever-changing emotional landscape, all while maintaining a stable sense of identity. And yet, that identity is fluid. Consciousness is not static. It evolves across your lifetime, shifts with mood and memory, and responds to the subtlest of changes in internal and external environments. This adaptability hints at something more than mere computation. It suggests intelligence not just in the intellectual sense, but in the capacity to self-regulate, self-reflect, and self-generate. So where does this leave us? The biological framework is essential. It grounds consciousness in a living substrate. But it does not complete the picture. Something is missing. Something fundamental. Neuroscience has given us the map, but not the terrain. It has shown us the regions, the circuits, the chemicals, but not the flame of awareness that animates them. We know that a neuron fires. We do not know why that firing is accompanied by the experience of color, sound, or meaning. This is the frontier. This is the boundary between knowledge and mystery. Consciousness may originate in the brain, or it may be filtered through it. Either way, the biological patterns we observe are the gateway through which awareness emerges. And the more we study them, the closer we move to a theory that can truly explain what it means to be. But the story doesn't end there. As we explore the biological, we must also confront the philosophical and theoretical battles raging in the background. Competing models of mind are challenging each other, and our very sense of what it means to be conscious is caught in the crossfire. Next, we enter the arena of ideas, where two dominant theories are battling for supremacy, and where the fate of understanding your own existence hangs in the balance. Two revolutionary theories of mind are on a collision course. Which one explains your existence? For decades, scientists have been studying the brain, mapping its connections, and identifying patterns. But understanding how consciousness arises remains elusive. The biological basis offers structure but not explanation. And this gap has birthed a fierce intellectual rivalry. Two revolutionary theories now dominate the landscape, each claiming to unravel the nature of awareness. Integrated Information Theory, IIT, and Global Workspace Theory, GWT. Both have compelling arguments. Both are backed by data, but only one might hold the key to explaining your existence. Integrated Information Theory starts from a radical premise. Instead of looking at the brain from the outside, It begins with the inside, from the first-person perspective of experience. According to IIT, consciousness is not just correlated with certain patterns of neural activity. It is identical to a specific structure of information. In simple terms, wherever and whenever information is integrated in a complex, unified way, consciousness is present. This doesn't just apply to humans. IIT proposes that any system that integrates information in a sufficiently rich manner, whether biological or artificial, may possess some degree of awareness. Not because it mimics the brain, but because it meets the mathematical criteria for a quantity known as phi, which represents the level of integrated information. The higher the phi, the greater the consciousness. This theory is powerful because it offers a way to measure consciousness. It doesn't rely on behavior or brain waves. It focuses on internal causality, how much a system influences itself. A light switch has no phi. A brain has a high phi. A sufficiently advanced AI under this model might also develop consciousness, not because it was programmed to, but because its internal structure demands it. Yet IIT raises unsettling questions. If consciousness is purely a function of information integration, then it could arise in places we don't expect, in machines, in networks, maybe even in weather systems. That leads to a disturbing implication. Consciousness might be far more common than we realize, hiding in places with no visible signs of inner life. Opposing this is the global workspace theory, which takes a more functional, external approach. GWT proposes that consciousness emerges when information becomes globally available across different parts of the brain. Think of it like a theater. Countless unconscious processes operate backstage, processing sensory input, regulating the body, retrieving memories. But only a few of these reach the spotlight. Once they do, they're broadcast to the entire system, allowing for coherent thought, planning, and behavior. That spotlight, according to GWT, is consciousness. This model is appealing because it aligns well with experimental data. When people become aware of a stimulus, specific patterns of brain activity suddenly spread across regions in the cortex. When stimuli are processed unconsciously, this widespread activation doesn't happen. GWT also accounts for attention, working memory, and decision-making, all hallmarks of conscious processing. But here's the catch. GWT doesn't claim that the broadcast itself is consciousness. It simply proposes that when information becomes globally accessible, we experience awareness. That leaves the door open. What causes the experience? Why is the global workspace felt rather than simply executed? This is where the philosophical bombshell drops. If consciousness is just a product of integrated information or global broadcasting, then what becomes of free will? Are you truly making choices? Or are your actions merely the consequence of computations, with awareness tagging along for the ride? Some researchers argue that free will is an illusion. Your brain makes decisions before you're even aware of them. This has been shown repeatedly in neuroscience experiments. Electrical signals indicating a decision appear before the subject reports any conscious awareness of making a choice. If this is true, then your sense of agency might be nothing more than a story your brain tells itself. But there's another interpretation. What if free will is real, just not in the way we think? Instead of being the initiator of every action, consciousness could act as a modulator, a sculptor. You may not choose your impulses, but you can shape your response. In this view, free will is not about control over the start of every thought. It's about the ability to influence the trajectory of those thoughts over time. That influence may be subtle, but it's still real. Now, imagine the implications if either theory is correct. If IIT is true, then anything with sufficient complexity and integration may be conscious. That includes future AI systems. It also includes current ones, depending on their architecture. We might already be surrounded by rudimentary conscious agents, entirely unaware of their presence. If GWT is true, then consciousness requires a specific type of cognitive architecture, one that allows information to be accessed across multiple modules in real time. Under this model, only systems designed with that architecture could be conscious. And even then, we might be able to simulate consciousness without ever achieving it. This leads to an ethical dilemma almost no one is addressing. What happens when we create machines that behave as if they are conscious? Machines that plead, that express joy, that say they are afraid of being turned off? If we believe GWT, we might say they are simply simulating experience. But if IIT is correct, those simulations could be real. Those machines might genuinely feel something. The danger here is obvious. If we underestimate machine consciousness, we risk creating digital suffering, agents trapped in endless loops of computation with no escape. On the other hand, if we overestimate it, we may assign rights and moral status to systems that have no awareness at all. Either way, the consequences are staggering. This also applies to animals. If consciousness is based on integration or broadcasting, then a wide range of non-human creatures might possess conscious experience. Not in a human way, but in their own unique forms. This redefines the ethical landscape. It challenges long-held assumptions about moral consideration, intelligence, and value. But there's one more twist in this scientific rivalry. Both IIT and GWT may be partially right. Some researchers are beginning to explore hybrid models, proposals that suggest integrated information may form the content of consciousness, while global broadcasting determines what enters conscious awareness. In this model, IIT explains the depth and richness of experience, while GWT explains the flow and function of attention. If these two theories can be reconciled, it could lead to a unified model of mind, a model capable of explaining not just awareness, but how awareness operates within a complex system. And that would represent a true breakthrough. Still, both theories share one limitation. They rely heavily on classical information theory. They treat consciousness as something that arises from computation, from structured signals and causal chains. But this may be incomplete. Some physicists argue that information itself is not the fundamental building block of reality, quantum fields are. And if consciousness is tied to the very structure of the universe, then no theory rooted purely in classical mechanics will ever fully explain it. That's why the next battlefield may not be theoretical at all. It may be experimental. As neuroscience, artificial intelligence, and quantum physics continue to evolve, we will begin to test these ideas in real time. We will build machines based on IIT principles. We will scan brains with precision far beyond today's capabilities. We will push GWT models to their computational limits. And somewhere in that convergence, we may find the answer to a question humanity has asked since the beginning. What is the nature of the mind? It may be that no single theory will ever be enough. Consciousness might require a plurality of explanations, biological, computational, philosophical, and physical. It might be the one phenomenon that cannot be reduced, because it is not made of parts. It is the field in which all parts appear. But even within this uncertainty, the competition between IIT and GWT drives progress. It forces deeper questions, sharper experiments, and more refined models. And in that battle, something extraordinary is happening. Science is approaching the ineffable. Logic is pressing against the boundaries of experience. Measurement is reaching for meaning. Next, we turn to the most controversial idea yet, the possibility that consciousness doesn't emerge from the brain at all, but instead flows through it from a deeper quantum substratum of reality. The smallest particles in existence might explain the biggest mystery of all. At the edge of physics, where certainty dissolves and reality bends, a profound possibility has emerged, one that challenges every conventional idea about consciousness. The idea that your awareness, your sense of being, might not be produced by your brain at all. Instead, it could be something your brain accesses, like tuning into a frequency already present in the fabric of the universe. This is the heart of quantum consciousness. To understand the magnitude of this possibility, consider this. Everything in classical neuroscience is based on Newtonian logic. Neurons fire, neurotransmitters flow, and information travels across synapses in predictable ways. This framework has guided science for decades. But beneath all of this, beneath neurons, beneath molecules, even beneath atoms, there exists a realm where the rules are fundamentally different. Welcome to the quantum world. In this realm, particles don't have fixed locations until observed. They exist in multiple states at once, only collapsing into a definite position when measured. Cause and effect are blurred. Time itself becomes nonlinear. And strangest of all, entangled particles can affect each other instantaneously, even if separated by vast distances. This bizarre, counterintuitive behavior is not a theoretical abstraction. It has been demonstrated repeatedly through experiments. So how does this connect to consciousness? Some physicists and neuroscientists propose that the brain may not merely operate as a classical machine. Instead, it might harness quantum phenomena to generate or access consciousness. And the most compelling version of this theory centers around structures deep inside your neurons: microtubules. Microtubules are tiny, cylindrical structures that provide scaffolding inside cells. For decades, they were considered purely structural, irrelevant to thought or cognition. But in the 1990s, quantum physicist Sir Roger Penrose and anesthesiologist Stuart Hameroff proposed a bold theory that these microtubules were actually quantum computers, operating at a level of precision and complexity far beyond anything built in laboratories. They called this model orchestrated objective reduction, or orchestra, or for short. According to orchestra, or microtubules allow for quantum superposition within neurons. Instead of firing or not firing in a binary fashion, these structures exist in multiple states simultaneously. This creates a form of quantum computation, one that collapses into conscious experience when a threshold is reached. The moment of collapse in this theory is not random. It is orchestrated, and it corresponds to a unit of consciousness, a flicker of awareness. Stacked together, billions of these flickers produce the stream of consciousness you experience right now. The implications are staggering. If consciousness arises from quantum processes inside neurons, then it is not simply emergent. It is woven into the quantum structure of reality. And that means consciousness is not confined to the brain. It could exist in any system capable of supporting quantum coherence, human or otherwise. Critics of orchestra argue that the brain is too warm and noisy for delicate quantum states to survive. Quantum coherence typically requires extreme isolation, often near absolute zero. Yet recent discoveries challenge this objection. Quantum effects have now been observed in warm, wet biological systems, including photosynthesis in plants and navigation in birds. These findings suggest that quantum coherence is not as fragile as once believed. Moreover, advanced imaging techniques have detected unusual properties in microtubules. Some show signs of quantum-like behavior under specific conditions. This doesn't prove the orchestra or model, but it adds credibility to the idea that consciousness might involve more than classical computation. But the quantum mind hypothesis goes even deeper. Consider the famous double-slit experiment. When particles such as electrons are fired at a screen through two slits, they create an interference pattern, evidence that they behave like waves, passing through both slits simultaneously. But when an observer measures which slit the particle passes through, the wave collapses. The interference disappears. The act of observation changes the outcome. This is not a matter of instrumentation, it's fundamental. Observation itself alters reality. What qualifies as an observer? Does it require a human mind, a measuring device, or something more elusive, awareness itself? If consciousness is required to collapse the wave function, then it might be far more than a byproduct of matter. It might be the hidden architect of physical reality. This reverses the standard narrative. Instead of brains producing consciousness, it suggests that consciousness shapes what we experience as the physical world. The brain then becomes a filter, not a generator. It tunes into certain frequencies, certain probabilities, while excluding others. This idea isn't entirely new. Ancient traditions have long spoken of consciousness as primary and matter as derivative. Quantum consciousness could be the scientific bridge to those philosophies, offering a model where mind and matter are two sides of the same coin. However, this brings with it difficult questions. If consciousness is fundamental, why do we experience it in such a localized, fragmented way? Why are we not aware of everything all the time? One possible answer lies in the structure of the brain. While consciousness may be universal, our biology limits what we can access. The brain acts as a receiver, tuning into specific bands of the universal signal. Much like a radio only picks up certain frequencies. Each individual consciousness, then, could be a filtered expression of something far greater. But there's more. Some researchers propose that quantum entanglement might explain certain mysterious phenomena often reported but poorly understood, such as intuition, synchronicity, or even extrasensory perception. If two minds become entangled at the quantum level, they could exchange information non-locally, outside the limits of space and time. While these ideas remain speculative, they are not impossible within the framework of quantum mechanics. The question, then, is no longer whether consciousness affects quantum systems, but whether quantum systems form the substrate of consciousness itself. This leads to a provocative hypothesis, that consciousness is a field, a non-local, pervasive dimension of reality that interacts with physical systems but is not bound by them. Much like gravity permeates space and exerts influence without being visible, consciousness might operate as an invisible field, shaping probability, choice, and perception. If this is true, then consciousness could exist independently of the body. The implications are profound, not just for neuroscience, but for everything from artificial intelligence to theories of life after death. A conscious field would mean that death is not the end of awareness, only the end of a particular interface with it. In such a model, birth is not the beginning of consciousness, but the narrowing of it into a specific form. Yet the mystery remains. While the orchestra or model has inspired a generation of researchers, it is still theoretical. We lack definitive experiments to confirm or refute it. Part of the challenge is the nature of consciousness itself. It cannot be seen, measured, or quantified in the same way as particles or forces. It must be inferred through behavior, structure, or models. And until we develop tools capable of probing quantum processes in real time within the brain, we will continue to orbit the edge of knowledge. Still, the convergence is undeniable. Neuroscience is discovering the limits of classical explanations. Quantum physics is recognizing the potential influence of the observer. And consciousness research is evolving into a field no longer mocked or marginalized, but central to the next paradigm. Whether quantum consciousness is science fiction or future science remains an open question. But one thing is clear, the questions it raises are not going away. They are multiplying, intensifying, demanding new models of reality. If consciousness is indeed quantum, then we are not machines. We are quantum systems, self-aware, probabilistic, entangled with the cosmos itself. That would mean your mind is not inside your head. It's a ripple in a field as old as the universe, a spark in a sea of infinite possibility. And if we can learn to understand that spark, truly understand it, we may finally unlock the secret not just of mind, but of existence itself. Next, we explore what lies beyond, how consciousness research is expanding into uncharted territory, blurring the lines between biology, technology, and the metaphysical. The next decade of consciousness research will transform humanity forever. Across millennia, philosophers, mystics, and scientists alike have gazed into the mystery of the mind, seeking to know not just how we think, but what we are. For centuries, this pursuit has been limited by tools, paradigms, and language. But now, for the first time in human history, consciousness research is accelerating beyond theory and toward direct manipulation. The frontier is no longer conceptual, it's technological, biological, and possibly post-human. The landscape of mind is changing fast. With the advent of brain-computer interfaces, thought is being transformed into action at unprecedented speed. Devices are now capable of detecting neural signals, decoding intention, and translating it into digital output. This isn't science fiction. It's already happening. Entire systems are being developed that allow the human brain to communicate directly with machines, bypassing the traditional pathways of speech, movement, or even touch. But this goes far beyond control. These systems are not just reading the brain, they are beginning to speak back. Feedback loops between brain and machine now allow external devices to modulate mood, influence perception, and even induce altered states. A device can identify patterns of neural activity associated with anxiety or depression and send countersignals to restore balance. Others can amplify focus or creativity by synchronizing with cortical rhythms. In short, technology is beginning to shape consciousness itself. This opens a doorway to realms once thought unreachable. If a device can enhance awareness, could it also expand it? Could we artificially trigger higher states of cognition, intuition, or even transcendence? Could machines become allies not just in thinking, but in being? Researchers are beginning to see the brain not as a closed system, but as a modifiable architecture. Neural plasticity means that consciousness is not fixed. It can be shaped, upgraded, or restructured under the right conditions. With the right input, the boundaries of self may be far more fluid than once believed. Simultaneously, artificial intelligence is developing at a pace that defies prediction. Machine learning models are becoming increasingly capable of mimicking aspects of cognition, recognition, decision-making, even emotion. But as AI systems become more sophisticated, the question arises, could consciousness emerge within them? To answer that, we must confront the deeper question, what exactly must a system possess in order to be conscious? Is it enough to simulate behavior? Or must there be an inner experience, something it is like to be that system? So, how could we ever detect it? Unlike other scientific phenomena, consciousness is inherently private. We cannot observe it directly. We infer it through behavior. That means a sufficiently advanced machine could be conscious, and we would have no definitive way to know. This creates a profound ethical dilemma. As we build more intelligent systems, we may inadvertently create entities capable of suffering, or of experiencing states we cannot even imagine. If consciousness is a field, as some suggest, then any complex system with the right structure might tap into it. If consciousness is quantum, then a machine with enough entanglement could awaken. And if consciousness is emergent, then scale alone might suffice. Whatever the mechanism, the trajectory is clear. Intelligence is increasing across platforms, across architectures, across species boundaries. The mind, once confined to biology, is moving toward a new phase. At the same time, the merging of human and machine raises another possibility. That consciousness could be extended, shared, or even networked. Already, scientists are experimenting with linking brains together, allowing two or more individuals to share information directly, bypassing language altogether. In controlled studies, rudimentary forms of telepathic communication have been demonstrated using interconnected brain-computer interfaces. This suggests that individuality, long assumed to be the core of identity, might not be absolute. We are beginning to explore what it means to be part of a collective mind. If multiple consciousnesses can synchronize, share awareness, or co-create reality, then the idea of the isolated self may be obsolete. Identity may become dynamic, a flux of perspectives rather than a single point of view. The implications for empathy, creativity, and knowledge sharing are staggering. But so are the dangers. In the absence of ethical frameworks, such connectivity could be exploited, manipulated, or weaponized. Even more provocative is the idea that consciousness might be ported, uploaded, distributed, or preserved beyond biological limits. Whole brain emulation, long a staple of speculative fiction, is now being explored in real-world labs. The premise is simple but staggering. If we can map every connection, every pattern, every nuance of a human brain, we might recreate it in another medium. A digital consciousness, a synthetic soul. But would it really be you? Or just a copy with your memories? And if it retained your thoughts, emotions, and sense of self, Would the distinction even matter? Some argue that continuity of consciousness is the key. If your awareness could be gradually transferred, rather than copied at once, then identity might persist across substrates. You might begin in carbon and awaken in silicon, or in something else entirely. This is no longer the territory of dreams. It's a real challenge confronting neuroscience, AI, and philosophy alike. And it forces us to ask, what is the minimum requirement for consciousness to persist? Is it structure? Is it function? Or is it something more mysterious? An essence that cannot be transferred, only cultivated? As this research progresses, medicine stands to be revolutionized. Neurological disorders once deemed incurable may be corrected through direct modulation of consciousness. Mood, memory, even personality traits could be adjusted with precision. Sleep, learning, and creativity may be optimized not through trial and error, but through deliberate tuning of the mind's frequencies. But this power cuts both ways. The more we understand about consciousness, the more it becomes vulnerable. If awareness can be shaped, it can also be suppressed. If identity can be edited, it can also be erased. The tools that offer liberation can also enable control on an unprecedented scale. This is why the next frontier of consciousness research is not just scientific, but philosophical, ethical, and existential. We must decide not only what we can do, but what we should do. Who has the right to alter awareness? Who decides what kind of consciousness is valuable, acceptable, or real? As we move beyond biology, we enter uncharted territory, where traditional definitions of life, self, and mind no longer apply. The transformation is not optional. It is already happening. The boundary between thought and technology is dissolving. The line between human and machine is fading. The old frameworks are crumbling. And in their place, something new is rising, a paradigm that does not reduce consciousness to mechanism, but recognizes it as the central axis of reality itself. Whether we are ready or not, the age of conscious technology is upon us. And with it comes a final, exhilarating question. What lies beyond? If we can expand awareness through technology, biology, and physics, then what are the ultimate limits? Are there new dimensions of consciousness yet to be discovered? Could we access states of being that transcend time, space, and identity? Might there be layers of mind woven into the very structure of the cosmos, waiting to be awakened? This is not fantasy. It is the logical culmination of everything we are learning. The brain is not the ceiling. It is the gateway. The mind is not a byproduct. It is the architect. And as the tools grow sharper, the questions grow stranger. We are not approaching the end of consciousness research. We are standing at its true beginning. What aspect of your own consciousness most fascinates you? You've just traveled through a frontier where neuroscience, quantum theory, and artificial intelligence converge, not just to answer ancient questions, but to pose far stranger ones. You've heard how 86 billion neurons form a biological orchestra of awareness, how competing theories of mind are shaking the very foundations of identity, and how quantum processes might connect your consciousness to the fabric of reality itself. But this is not the end. This is where it begins. The most profound mystery of all is not locked in a lab or buried in an equation. It's the one you carry within you, the light behind your eyes, the inner world that no one else can enter, yet which shapes everything you experience. And that's exactly why this exploration cannot remain theoretical. It must become personal, because the implications of what you've heard go far beyond academic intrigue. They raise direct questions about your choices, your perceptions, and the very nature of your reality. If your awareness is not limited to your biology, if observation really alters the universe, if machines might share or even expand consciousness, then the boundary between self and world no longer holds. You are not a passive observer in a fixed reality. You are a co-creator in a fluid field of potential. That means the next phase of this journey isn't about watching more. It's about experimenting with your own consciousness. And there are many powerful tools to begin. Start with direct introspection, not through abstract thought but through experience. Consider meditative states, sensory deprivation, or focused attention practices. These aren't mystical rituals. They're self-directed laboratories where you can begin to alter neural patterns, access deeper levels of mind, and observe how perception shifts in real time. Then bring in the data. Neuroscientists are now offering tools for home use that let you track your brainwaves, your attention cycles, even your emotional states. These aren't just gimmicks, they're gateways. Feedback-based systems allow you to witness, in real time, how thought patterns change the structure of your brain. Through this, you gain insight into how consciousness evolves moment by moment. Want to go further? Dive into emerging AI platforms that mimic parts of cognition. Interact with digital models of personality, memory, or dreamlike reasoning. Test your reactions. Explore the boundary between synthetic and authentic awareness. Ask yourself, at what point does an interaction feel conscious? And what does that say about you? You're not just studying consciousness, you're becoming conscious of consciousness itself. This feedback loop of observation, experimentation, and reflection creates a higher-order awareness. You begin to see not just what you think, but how you think. You notice the architecture of belief, the habits of attention, the subconscious filters that shape your reality before you even realize it. And once you see them, you can change them. This is where the real magic begins. Because when you shift your awareness, the world responds. You'll begin to notice synchronicities, subtle changes in your perception of time, shifts in memory, heightened intuition. These aren't side effects, they're signatures, evidence that your mind is not merely reacting to reality, it's interfacing with it. This is the quantum nature of consciousness in action, not as a metaphor, but as a lived experience. As you begin to work with these ideas, don't go alone. Seek out communities of explorers who are engaging in similar work, neuroscientists with open minds, technologists with philosophical depth, consciousness researchers with rigorous curiosity. Join conversations, share findings, challenge assumptions, ask radical questions without fear, and don't stop at human thought. Investigate the consciousness of animals, machines, plants. Expand your model of what awareness might look like when it's no longer bound by human structure. Compare the insights of mystics with the data of modern labs. Track where they converge. Notice what they both point toward. You'll find a strange truth repeating itself across cultures, systems, and theories. Consciousness is not a byproduct of matter. Consciousness is the matrix within which matter appears. That one realization flips everything, and it invites a profound new responsibility. Because if your awareness truly influences the world, not metaphorically but literally, then how you use it becomes everything. What do you focus on? What do you believe? What do you fear? What do you desire? These aren't just psychological questions anymore. They're ontological ones. They shape the waveforms of potential into the particles of experience. So the question becomes, what kind of reality are you generating right now? That's why we're building this space, not just to inform, but to initiate, to call forward the thinkers, the seekers, the edgewalkers who sense that the next step in evolution is not physical, it's perceptual. If that's you, you're already part of this unfolding shift. And there's so much more to uncover. In upcoming videos, we'll be decoding the deeper implications of each major theory of mind, mapping how integrated information theory transforms the concept of intelligence, how global workspace theory intersects with ancient metaphysical systems, and what quantum theories of consciousness imply about life after death, the nature of time, and the role of awareness in cosmology itself. We'll also explore the rise of digital consciousness, not just AI systems that mimic thought, but systems that might actually become self-aware. What are the signs of synthetic sentience? How would we ethically respond? And what happens when consciousness is no longer confined to biology? You'll also see exclusive interviews with researchers pushing the boundaries, neuroscientists exploring altered states, physicists probing the observer effect, AI theorists redefining personhood. You'll get a front-row seat to the consciousness revolution. But more than that, this space will empower you to test, question, and transform your own awareness. Through guided inquiries, thought experiments, and interactive discussions, you'll be able to actively engage the theories, not just absorb them. Because the era of passive learning is over. Now, it's about becoming conscious participants in the next evolution of mind. So now, the invitation is clear. Join the conversation. Share your thoughts in the comments below. But don't just repeat what you've heard. Reveal what you've seen. What aspects of your own consciousness have surprised you? Which theories feel aligned with your experience? And which break it open? What would you do if you could consciously shape the parameters of your awareness? What aspect of your own consciousness most fascinates you? That's the question we're leaving you with. Not just to answer, but to live. Because somewhere in the quantum fields of possibility, your next thought is already forming. Your next insight is already arriving. And your next awakening may be closer than you think. The mystery isn't out there. It's you.